Okay, this question's been causing a few problems, so I'd like to do this one a little bit, show helpful advice for you guys on this one. So in the diagram, it's not quite clear, but what's important to understand is that this is the center of a circle. So the blue circle that we see drawn here, let me try and draw my circle. Yeah. So the blue circle that I've sort of drawn here is the circle that we're trying to find the center of the arc from. So the diameter of the circle is going through here like this. This is where the diameter of the circle is. And we're asked to find the radius. So what we need to do is we need to first start by finding this angle in here. So this angle here is going to be 135. We've got a 360 degrees there. This one gets us to 135. What we're left with is we know that this dotted line there is going to be the same length as we're seeing here, 420. So this dotted line is 420. And this is an isosceles triangle because that's the radius that we're after, but so is this. So if this is a radius and this one is a radius, we can work out what this angle is here. Because we know if this angle is x, this angle is x. We can put up the equation from the triangle there that 180 is equal to 135 plus 2x. So we just do that on the calculator. We get 180 minus 135 and then divide that by 2. Just going to make that into a decimal. 22.5. So x is 22.5 degrees. So now we can pull off a right angled triangle. If I draw a triangle like this one here. We'll try that again. This is a right angled triangle. So that right angled triangle I'm drawing there. It's going to have a length here at this point of 22.5 degrees. And then we can figure out what this length here is across the top. So this length here across the top, that's going to be half of 420. So this length here is going to be 210 meters. So now we can use SOHCAHTOA. This is the adjacent. This is the hypotenuse, and then we have the angle. So we're going to use K from SOHCAHTOA to find that one. We're after the hypotenuse. So the hypotenuse is going to be equal to the adjacent, 210, divided by the cosine of 22.5. Let's try that on the calculator. Control divide. We need 210 divided by cosine of 22.5. Control enter. And this gives us 2.27 meters. So this is part A. Part B, what is the length of the arc to the nearest centimeter? Ooh, so that answer there, look at this, wait a second. This is in meters. This answer is to the nearest centimeter. So that is 227 centimeters. Make sure we give the answer correctly. So in B, length of the arc to the nearest centimeter. So length of the arc is the angle over 360 degrees times by 2 pi r. Putting our values in, our angle that we're going to use, Let's make sure I get this one right. Yeah, we are there. We are 135 over 360 times by 2 pi, and then we need to use 22,227. Let me do this on the calculator. So we're going to need 135 over 360. Oh, let's type there. 360 times by 2 times by pi, that's here, times by, I'm just going to scroll up and copy that down because I want to use the exact value. Always carry the exact value down, even though you rounded in the previous one. And we get this. This is in meters, remember? So we need 536 centimeters. There on that one. Okay, that's it for that one. Thank you very much.